Today we're going to identify some of the rules that we need to follow if we're going to simplify problems that use values in index notation. So let's begin. So let's consider for a moment what it actually means to have 2 to the second power multiplied by 2 to the third power. If we actually wrote this down in extended form, 2 to the second power is the same as 2 times itself twice. Then we need to multiply that by 2 to the third power. 2 to the third power is going to be 2 multiplied by itself 3 times. Now when you write this down in extended form, you immediately notice that we can simplify this further than what was written above. We can write this as our base of 2 and then count how often it multiplies together, which is a total of 5 times. Now there's a rule that we can use here that's much quicker than having to write down the expanded form. So let's consider the exponents here in 2 squared multiplied by 2 cubed. When we're multiplying two bases together, we keep the base the same. However, the power will change. The power will be equal to the 2 powers here added together. So this statement simplifies to 2 to the power of 5. Which brings us to our first rule. If we multiply two indices with the same base, we keep that base and we add the two exponents together. Okay, so that's a neat trick for multiplication. But what if we're dividing like we are here? We've got 3 to the 5th power divided by 3 to the 3rd power. Well, let's write this out in expanded notation. This is equal to 3 times itself 5 times on the top of the fraction divided by 3 times itself 3 times on the bottom of the fraction. Now we've written it out like this, we can instantly see we can start cancelling out. So let's cancel those two out, those two out, those two out. And what we're left with is 3 times 3, which can be written as 3 as our base and as 2 the second power. However, like last time, there's a quicker way that we can do this. So if we consider 3 to the 5th power divided by 3 to the 3rd power, because the bases are the same, we keep the same base, but we subtract the bottom power from the top power. So it's 5 subtract 3 is equal to 2, so our answer is 3 to the second power, or 3 squared. So this leads us nicely to our second rule. When we're dividing two indices with the same base, we keep that same base, but we subtract the exponents. Alright, so let's step it up a bit. What if I've got 2 cubed multiplied by 2 to the 6th power multiplied by 5 to the second power? Well, I first need to group together those that have the same base, in this case the number 2, and apply our first rule. When multiplying two indices with the same base, we add the exponents. So that is going to be equal to 2 to the power of 3 plus 6. However, we're still multiplying by this 5 to the second power, so we keep that in the problem. Now, 3 plus 6 is going to be 9, so that's equal to 2 to the 9th power multiplied by 5 squared. Okay, so let's have a look at the second problem over here. I have a division symbol. However, I've got to be very careful because there are actually invisible brackets that we don't write on both the top and bottom line. So the first thing that I actually have in this problem is a multiplication. So I've got to use rule 1, where if I'm multiplying two indices with the same base, I add the exponents. So that is going to be equal to the base of 4, add the exponents of 2 plus 7, all over 4 to the 3rd power. That is equal to 4 to the 9th power divided by 4 to the third power. Now I've simplified it with the first step, I bring in rule 2 that says when dividing two indices with the same base, we subtract the exponents. So here, this is still going to have the base of 4, however, it's equal to 9 subtract 3 in its exponents. 9 subtract 3 is equal to 6, so our final answer is 4 to the 6th power. So now it's your turn. Remember, when simplifying each of the following, to apply rule 1 and rule 2 as long as they've got the same base. When you have a division problem, don't forget the invisible brackets that exist on both the top line and the bottom line.